Okay, so help me draw the diagram. Who can get us started? Megan. All right, horizontal line, and you said it's 100 feet. Oh, is this not going to work? Okay. No. Whew. 100 feet. So you say that's 100 feet? Yes, it is 100 feet. Yeah, that's the right measurement. But you're saying that's where I put it? Okay. And what does that stretch between researcher 1 and researcher 2? It's two researchers. We can call them R and S. We don't have to call them anything, but maybe you want to come up with names for them or something. Albert and Bob, A and B. Okay, good. What's next? So 100 goes all the way from here. Sometimes when we have more than one triangle, it's really important to show where a measurement starts and ends. Otherwise, it's not clear in your diagram where the 100 goes to. In this case, it might be fine. We might get away with it. I don't know. Okay, what's next?
A 47 degree angle at one of the sides, the left side.
Okay, so I'm going to just draw it kind of up into the air somewhere like that. Is that okay? And call that 47. Good. What else? Jaden? Okay, good. See how useful it is when we name. Ooh, that wasn't very good. When we name points, you can say, like, you go from there. That wasn't very great, but to S. So we could call this T for tree. Get it? RST. Yeah, okay. From T to S, like, it's just easy to talk about. Okay, what are we missing? We're missing one thing here. What are we missing? Right? The tree. I'm going to put a green tree in here. What do we know about trees? Every single tree in the world. When you're in math class, is that a perfect right angle to the ground? That's true, isn't it? Okay, good. What are we missing? Yep. 38 degrees there. Awesome. How many people got this as the diagram? Very good. Now, what are we trying to find? We're trying to find the height of the tree. I'll call it H. How do I do that? Can't do it directly, can we? Megan. RT. Okay, good. Very good. So that's RT. Or I could call it little s because it's across from S. Or I could call it X. It doesn't matter. We were talking about this over here. When you have two triangles, angles are across from more than one side length. So which one would you call S? There's no rule about that. When you have more than one triangle, it's going to get complicated. So that idea of S across from S is not necessarily as helpful. In your own diagrams for an application like this, call it what you want. But call it something, X, Y. H for height is a nice one. Use A, like whatever you want. But call it something. Or RT is a good way of describing it, but then we'll give it a value, a variable for its value. How do I find X now? This is a non-right triangle. Liam? Sine law, very good. This is from yesterday. We talked about how do you know when you use sine law, when you use cosine law. So if you're not sure, you need to go back and watch that video. Okay, so for X, I'm going to get, you could even say for X. I'm going to use sine law. I'm finding X, so I'm finding a side length. So I'm going to use this one, A over sine A equals B over sine B. What's my A, what's my B? Whoops. So X over, Ziggy, what do you think? We're plugging in values. What goes X over what? I feel like people are hiding and trying not to answer. Tony, what do you think? X over, how do we figure it out for sine law? And in this case, that's nice. So sine 38 equals, you want to keep going? What's the rest of it? Oh, we're missing a step here. We forgot something. What did we forget? Nice. Do you know what it is? 38. Yep. 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 95. Nice. Thank you. We forgot to find that angle. Now that I have that angle, I've got an angle and a side length across for them. Is that true? So my side length is 100. My angle is 95. And I ran out of space. X equals 100. Go ahead and solve that, please. We're going to use this in the next step. So what do you need to remember? Keep a whole bunch of decimal places. $61.8, is that right? Yes, thank you. 61.801320221. I'm going to leave that on my calculator and use that. Okay, what's next? You might want to label, like put that in, 61.8. Now I know that. Might help you visualize what you know, what you need to find. The other thing is, sometimes it helps when you have these questions that have multiple triangles in them to redraw it as a single triangle. So I could have done this. 100, 38, 47, and then this works out to be 95, and this is my X, and I've got that and that, right? You might be able to visualize it a bit better when you do it like that. Might help. Whoops. And now, what are we doing next? Megan? Or I called it H. Oh, are you mean this one? Why? Do we have to find that? You did? Okay. Did you find H? Okay, go ahead. You could find it, and sometimes you end up finding more than you need. In this case, you don't have to. We only need X. So how do I find H now? Who knows, Alan?
Go from 47 to H.
Yep.
And then 61 to 90.
And you're saying to use sine law. That would work, although it's a right triangle. So we don't typically use sine law and cosine law in right triangles. So how could I simplify that a little bit? Jaden? So SOHCAHTOA stuff. Okay? And again, I could redraw this. It would look like this. 47, 61.8 right angle. This is my hypotenuse. There's my opposite. And I'm doing sine, not sine law, sine, right? Okay, let me get rid of that. So let's do it. So sine theta is opposite over hypotenuse. Sine 47 is opposite, which is my H, over my hypotenuse, which is my 61.8. Notice I'm only writing 61.8, even though I do have all four decimals and I have even more on my calculator. You don't have to write them every single time. As long as your final answer is perfect, then I'll know. So on my calculator, I just go times sine 47, and I get my answer. The height is 45.2, therefore the tree is 45.2 feet tall. Any questions?